Okay, this is a circular motion example. It's our first one. This is where we're going to be doing circular motion, and we're just going to look at acceleration, velocity, and force. You've got your formulas here for circular motion. This is linear or tangential velocity. This is your acceleration towards the center of the circle. That's your force towards the center of the circle. That's just Newton's second law, and then I've just plugged in your A value here. So mass times velocity squared over r. You'll notice that I use capital R here. That's radius. For some reason in circular motion they use capital R's, but I'm going to change back and forth. I've written out a question here for you. A 200-gram ball revolves in a horizontal circle of radius 0.6 meters. The ball is going to make 3 revolutions per second. You want to find FC. So let's just draw a picture of what's actually happening here. It's a vertical circle. Or sorry, no, it's not a vertical circle. It's a horizontal circle. You've got a center point. We're looking at a top view down. You're going to have some sort of a rope attached to some sort of a mass. The mass itself is going to have some sort of tangential velocity. It's going to have an acceleration and a force towards the center, your AC. You're told some information. First of all, you're told that it's 200 grams. You can't use grams. You've got to convert that to kilograms. So you divide that by 1,000. That gives you 0.2 kilograms. You're also told a frequency, 3 revolutions per second. That's 3 hertz. And you're told a radius of 0.6 meters. And you want to find AC. There's a way to do this in one step. I'm not going to do it in one step. I'm going to do it in 2 so you can see what I've done here. Okay, what I'm going to do first, my first step, is going to be to find my linear velocity. Or I'm just going to call it velocity. Sometimes you go V linear. That is 2 pi r over the period. Well, I don't have the period. I have to use my frequency to figure out my period. Frequency is 1 over period, so period is 1 over frequency. It's an old grade 11 concept. So your period is 1 over 3, so when we start plugging in our values here, V equals 2 pi, my radius is 0.6, period is going to be 0.33. When I plug that in, I'm going to get a linear velocity of 11.4 meters per second. And that's just a tangent to whatever the circle is, wherever you are. So if I was here, I would have that same linear speed, except it'd be that way. It'd be down or whatever, right? This one could be here. It's going to be that way. So you really don't have a direction for your velocity. You just say it's at a tangent to the circle. This 11.4 is your speed that if at any point in time, if I cut this string, this would fly off in a straight line at that constant velocity. Okay. The second thing I want to do is I want to find my acceleration. I want to find my AC. Well, AC is V squared over r. Okay, this velocity is this one we just found. The radius is what we're given. So AC V squared is going to be 11.4 squared over 0.6, and you're going to get quite a big 11 squared over 0.6. It's going to be pretty big. It's going to end up being 217.3 meters per second squared. And that's towards the center. Towards the center. I don't like how big that is, so I'm just going to double check to make sure that my math is okay. 11.4 squared divided by 0.6, 216. 216.6, which is 217, so I don't know if I've rounded differently. No big deal. I've only been asked to find the centripetal acceleration, but it's a small little step here. Your third step, if you wanted to find your centripetal force, so the force towards the center, MA, force towards the center, or I don't know why I'm writing AC, it's just FC. Force towards the center is going to be your mass. It's 200 kilograms, so that's 0.2. Acceleration I just found, 217. So my FC ends up being whatever that multiplies out to, 43.5 newtons. That's the tension that you would feel on the rope, or that would be the force towards the center. There you go. Enjoy.